Okay, let's get started. Our next talk will be given by Professor Mingyan Ken. Professor Mingyan Ken is an associate professor and vice dean of undergraduate studies at the National University of Singapore. Ming is an active member of the Association of Computational Linguistics, currently serving as a co-chair for its ethics committee. He is also the survey editor for the Journal of AI Research. His research interests include digital libraries, natural language processing, and information retrieval. He leads the Web Information Retrieval and Natural Language Processing Group. Let's welcome Professor Ming.
Hey, hi everyone. Thanks for coming to this talk and a very good afternoon to all of you. I know it's very tiring and you only have coffee in the afternoon, so it's a little hard to stay awake, but I promise to give you more of a broader view talk rather than talking about research publications. So this started with a sabbatical visitor, Uran Beal. He came to my university from University of Secrets, and he had this idea of spending his sabbatical and thinking about the frontier of IR research. So he actually worked with me and one of his master students to produce this SIG-IR forum paper that was pre-printed. As a couple people have said before, preprints come out way before the actual publication. But we critiqued the Sakana AI and found it a bit wanting, but also quite intriguing in its capabilities. And over the course of this afternoon and morning, we've heard a lot about what capabilities it has. So I gave a couple versions of this talk before, and I want to start with the idea of a research manifold. So what is a manifold, right? It's a mathematical term. It's a set of points, right, that encloses a surface. So you can think of it like as a circle or a sphere, right? And when we talk about this, I'm sure you've seen some diagrams a little bit like this one, where you say you have a sum of human knowledge, and maybe the blue one is like your undergraduate knowledge, and then the orange one is like master's knowledge. And then as a PhD student, what are you supposed to do? You're supposed to find the edge of human knowledge and poke it a little bit further out, right? So this idea is you blow up that little square region there, right? And then you make a dent in the future of research, and that certifies that you're a graduate, right? You have furthered human knowledge, right? So I'd like to think about this manifold, right? This is the manifold of all human knowledge, right? And the question that I have for us is, what does it look like when we put all of ourselves on this manifold? What does it look like? So I have this idea about the loss function of human research, right? So you have, let's say, a convex or a not very convex plane or manifold where people are scattered on this diagram, okay? And you can think of those points on a vector space, right? And you might think of us all having research agendas, right? And each person on this point is trying to get a publication or impact the area, right? And if you think about this as a loss function, then there are curves which are more easier to publish and some curves, some spaces that aren't, right? And if you do the normal thing, which is optimize, right, then you're looking for some type of optimal space, right? So you want to do stochastic gradient descent, find an area of research that's easy to publish, easy to make impact, right? And recurse on that idea. Okay, so then you can think, okay, well, these are particles in space, right? But how about all of us because we're not just points, we're points in time, right? You can think of each research publication as just one partial observation of a scholar that's moving around in this space, right? All of us have this image in our heads. Yeah? I know it's late in the afternoon, so it's hard to concentrate. Okay, but the idea is like you and your colleagues are moving around in space on this manifold, right? And we are butting our heads together, sometimes interacting and sometimes making observations. Bang, archive paper. Bang, published journal, etc., right? And then we get influenced by that. In fact, when I tell my students to think about publishing work, I always tell them, think about the trajectory of where people are going, right? Because let's say you're looking at a competing or a collaborative group. They're also doing AI for science, right? Everyone in this room is doing AI for science. Let's be honest, right? That's why we're all here, right? But you need to know where they're going, right? Not where they were as of January 2026, because that's published. You know, you can't be catching up to them. You have to go ahead of where they are, right? So that's very important. So trying to think about that idea of the manifold and how our things like today are influencing that are very important. Now I'm going to turn a little bit to something I'm sure everyone has heard of, right? This is Kahneman's fast and slow, right? But I gave a keynote at Coling in 2018 where I talked this idea about research fast and slow. So quite a long time ago before we really popularized this idea of having system one and system two. Okay? And of course, we know that system one means it's intuitive, something that can be done very fast, perhaps using a neural network like a CNN that just can recognize objects, right? And system two is much more deliberative. It's much slower. It has to take in lots of information and deliberate reason in order to get its understandings, right? And when we impact all of these things, system one and system two, okay, I want you to just put in the back of your mind, when we have all of these methods of AI for science, what type of research are we enabling more of? More of system two or more of system one? Okay, so this is a nice graphic. There was an earlier version popularized out there, which I used, but then I was actually corrected when I went to Schloss Dagstuhl. I met the original person who created this graphic, and she said, "Oh, I have a newer version from 2018. That was just their theoreticalized one." So you can see here, you know, there's this time point here in which research is published, right? And even before the research is published, you know, all of the games that we play in marketing our research are already done, right? People post on X, they put it on archive, etc., right? And then maybe many months afterwards, the research is published, and there's a lot of traction, perhaps in news media, in other forms of information, and finally, perhaps that gets implemented into policy and things of this sort. Okay, but because the time scale that we are doing our AI for science or just science in general is getting shorter and shorter, right? Then we are incentivizing research going faster and faster. And that's a good thing in part. But I'd like to ask you, is this really what we want as a community? Could it be that sometimes we are going research too fast? We are not solving all of the problems that we need to solve. And that's what I would like you to call your attention to. So here is a picture in the background of a scientist and an assistant. Who can tell me who is the scientist? This is supposed to be an interactive keynote, by the way. Come on, humor me. The guy's the scientist. Yeah, there's only one guy here, right? Actually, he's the assistant. The system there is an automated scientist. The assistant there is just to refill all the reagents needed to do the experiments, right? Okay, so what I'm trying to say here is that there's a lot of things that we are doing as a community that is incentivizing faster and faster research, right? We have archive, right? We preprint things before they're peer reviewed, and it's our reputation up at stake. You know, we don't need peer review to push out things, okay? And in Chinese, especially here in Singapore, because I'm from Singapore, but I'm actually American, but I work in Singapore, okay? There's this notion you probably have heard over the last week or so, kiasu, right? Kasu means fear of death, right? It means fear of missing out, FOMO, right? So our undergraduates and even our postgraduate students, they're very worried about publishing. I'm sure some of you as PhD students are also worried, right? So this is relentless drive to publish very quickly, right? And we incentivize that to a large extent too, right? Why? Because we have things like reproducible code. There have been a lot of talks here where I've heard questions like, oh, can I have the code base for that because I'd like to replicate your experiments, right? And that's a good thing as well, right? There's Jupyter notebooks, executable things that we can ask agents to execute as well. There are shared tasks. Again, Trek, if you follow the IR community, has been doing this for decades, right? Having shared tasks where we do Cranfield-based evaluations for things of this sort. And we also heard a lot about metrics, right? Being able to have a loss metric, optimizing that using RL or other things so you can tune a system using supervised tuning, in-context learning or other things to try to optimize an objective. Okay, all of these make it easy for us to do AI for science using agents. Okay, so let's go back to this manifold. What happens when we have accelerations? We make the gradient a lot steeper. Why is that? Because when we make certain pathways easy by making preprints, by making shared tasks, by making GitHub code, we make it easy for scholars to do certain tasks. And that's by design. That's why we do these things, right? Yes? Okay. But we also are making it hard to pay attention to other areas of research, right? Because there's so much work going out there. If we have AI scientists producing AI papers, then the overload that we are experiencing is going to be even bigger than before, right? Then how are we going to do that? We, as humans, we invest years, decades of our lives specializing in one area, right? But we are not AI agents. We can't do randomized restart. We can't start somewhere else on the manifold, but our agents can, right? So we end up perhaps pursuing suboptimal minima because we have incentivized certain agendas that may or may not be what we want. So what happens when we have another agent in the picture? Okay, that was just with assistance. But what about an LLM? What is an LLM going to do in this area? So you've seen all those animations in a high school physics class, right? A big body like Jupiter warps the space-time, right? And then things start to orbit around it. They can't escape from its gravitational pull, okay? I think all of us understand that using LLMs will have this consequence as well. All right. If we don't guide our research properly, we'll be influenced into thinking in a certain way because we have outsourced certain key decisions in the scientific process to an LLM. And that favors only certain types of solution spaces, okay? Which means that we'll regress to the mean because LLMs, in fact, are representative of their training data, right? So if we give it excellent training data, fine. But if we need enough data, then we will get information from a larger set of volume of articles, maybe preprints that are not peer-reviewed. We just hope that we're doing the right thing. We'll incentivize and create good outcomes. All right. So if you buy my analogy, then I will tell you a little bit about what I've been thinking over the last couple of years on this higher plane of space, not related directly to research papers. So there's this nice book called Where Good Ideas Come From. I encourage all of you to take a look at it. It's written by this very nice guy, Stephen Johnson. You may actually know him. He's one of the co-creators of Notebook LM. Okay, how many of us have used Notebook LM in some way or another? A couple brave hands? Yeah, okay. I can see some calories being spent. Okay, very good, right? And he says a couple different things here, right? He says that there are several different ways that we can incentivize how good ideas can emerge organically. All right, I'll come back to them in a little while. How many people know this person on this slide? Thomas Kuhn? Okay, he is a very interesting guy because he wrote the manuscript, The Structure of Scientific Revolution. Okay, he's a foil for another person, Karl Popper, who you may have heard of as well. Karl Popper is also a science of science scientist. Okay, he theorized that science is only science because it's falsifiable, right? If you have a hypothesis and you can falsify it, then it becomes scientifically valid. Okay, so Kuhn was his foil. Okay, in the 1960s, around the same time that we had uh, um, a couple of very important people in the digital library space who imagined hypertext, Vannevar Bush. Okay, he said that there is this idea of a paradigm shift. Okay, everyone has heard of that term before, right? So the paradigm shift happens because of what's on this slide. Okay, let me see whether I can point using this. Okay, it doesn't work. So I'll just point using the laser pointer. Okay, we have this pre-science era where there's a lot of observations, and then people start to come up with a hypothesis. Okay, so during this normal science phase, there are iterations of improvements to a modality. Okay, like we get better telescopes, better measuring devices. Okay, we can get better measurements, but at some point, there is a problem because some of those calculations and observations don't accord to the scientific theory. Okay, like Copernican astronomy doesn't quite add up. We can't see circular orbits. In fact, they look like they obey something else, right? Then we come up with this idea of an elliptical orbit, and then we have a new version, a paradigm shift that happens about that. Okay, so there's this idea of a paradigm shift where the data doesn't support enough of the science and the modeling, which encourages us to abandon old theories and create new ones, right? Now, my question is at the bottom of the slide, right? What role does AI play in this, right? What role do we as human scientists want to play in this grand endeavor of research, which many of us will argue that's why we spend so much time getting this, permanent head damage, if you will, okay? So Stephen Johnson argues that in the way that we do scientific thinking, we want to merge together what we can do from system one and system two, right? So a couple things here that I'll expand upon, okay? Just a adjacent possible, okay? Where we look at theories that are nearby, but not in our area of expertise. This is why professors always encourage their students to go to allied seminars that are not directly in their space. But of course, you ask the professors to go and they're too busy, right? Okay, that's a joke. Did you laugh? No. Oh well, doesn't matter. Okay, but the whole idea is like if you can go and have a chance to see other problems, you can make associative connections between areas that we currently cannot see because you're using your association, you're challenging your cognition to make sense of something on your own terms. This is why interdisciplinary research, many people will tell you it's extremely hard because I talk chicken and they talk duck, and we have to find a common language, right, of poultry or whatever, okay? But it's rewarding because you get a sense of a different perspective of what it means to think about a problem in a more broad context, right? We can solve wicked problems and other things that impact multiple areas because of this. Okay, another one that I'll just call attention to because I know a lot of people don't know this is exaptation. So what is exaptation? It means taking something that was purposely built for another solution and using it in a new space. Okay, the example that Stephen Johnson uses in this book is IKEA furniture. Okay, what does that mean? It means that there are so many objects created by IKEA that are already very inexpensive because they're manufactured in mass markets, and then you can reuse them to do all sorts of interesting crafts and hobbies because these things are already ready made for you, okay? It's to use existing tools in a new platform, a new situation, a new scenario. And in some of the works that we do in my group, we look at exaptation in math, right? So many times, for example, in machine learning, in natural language processing, in IR, we can borrow statistical physics, formulas from other places, right? EM and all these other things, Kullback-Leibler divergence, right? All of these things we can borrow from other fields and reuse them in the space for a specific purpose. So when we try to do this, when we look for things at system 3, which is the integration of system 1 and 2, we can open up the gradient. Because we are ignoring it, we're saying, you know, we have all of these shortcuts for doing things, but sometimes we need to say we have to go beyond benchmarks. We have to go beyond shared tasks. We have to flatten out the gradient. Okay, make it easy for us to go in different directions. Now, many of us will think, okay, is there analogy that we can use in inference, in LLM inference? Okay, and the first thing you would think about is temperature, right? Temperature allows us to say, flatten down, make a more uniform assumption, and ignore logics to a certain extent, right? So we can use temperature as a way of doing that, but it's not enough. And I'm going to argue why it's not. So adjacent possible is a type of reasoning, okay? And Stephen Johnson gives this very nice analogy. How would you be able to even think about inventing the microwave in the 1600s? No, couldn't happen, right? It's just too far-fetched. There are too many intermediate steps to get to that point where you could say, I'm going to use radiation to melt objects, you know, and heat them up and only heat certain molecules, right? Some of those even prerequisites were not even available at that time, right? It's beyond the bounds of possibility. But we can argue, in many cases, we can use simulation to roll out what we're doing with science as potential events, right? Many times nowadays, even in AI for science simulations that we have been talking about over the last day or so, happen in this case, where we're starting from a start point and we're using LLM rollouts to build steps at a time, right? And then figure out a step forward to get to a potential event. So I had this exercise that I did at my university when we want to do strategic thinking, something for the long term. And we work from the other direction. We say, okay, now it's 2035. Okay, so what is happening now? Because we were in NUS very concerned about AI's influence on education. I'm sure most of us who are professors were very worried about the cognitive debt that students might be having, right? So what do? We ask our colleagues in the sciences to think about writing a postcard as if they were in the future, and then asking either students or governance, meaning the NUS Board of Management or Board of Trustees, what are the types of things that are happening in 2035 that would help them understand how to solve that problem today. So to do this exercise, you sort of have to do some free association. And one of the things that we ask them to do is do green light thinking, okay? Green light is when we don't have a specific agenda in mind, we let free association reign, right? Jot down any thoughts that you have, let them wander around, take a tangent, talk with people, observe the background, and think, freely associate, come up with new ideas, right? Don't try to censor any of the observations you are making. Let them percolate and bang into your thoughts and recombine. Okay? Then the opposite of green light thinking is then, of course, red light thinking. Red light thinking is what currently we have the most work on in AI for science, right? When you talk to most people on AI for science, what do we say? We say that, you know, when we come to ideation, right? LLMs can give lots of ideas, but the problem is giving ones that are sort of aligned to the problem of expertise, right? There are certain physical constraints or other types of budgetary constraints that make certain ideas infeasible, right? And so teaching an LLM what is the red lights that we need to obey when doing ideation has been the cornerstone of a lot of what we're doing in domain-based AI for science. Okay, so we need them. We need to be able to do this well, but we also need to work on how to do the green light thinking very effectively as well. So this leads me to a point. Up until this point, I told you we did postcards in the future, 2035, walking backwards, right? So this is what we call in search, backward search, right? You work from the goal and you say, what are the steps needed, right? When DeepSeek or other agents do this, they're actually doing it in this way, right? They're saying, I have an objective. I want to divide and conquer, break it down into steps and reverse engineer what I need to go, right? And we are also working from the forward direction. Many times our chain of thought is in the forward direction, right? So just like you've learned in your AI classes, during undergraduate, you can combine both of these modalities, right? You can do bidirectional search, right? So when we think about doing search in agentic ways, we should think about how we can do this, not just in a rollout fashion, either forward or backward, but have some intermediate stop points which we can well define, have a good specification of it, and help us drive the agentic framework forward. Well, sometimes working backwards doesn't work very well because actually when we do rollouts or roll-ins, we have some problems with understanding context. Now, I get these questions once in a while from people who say, well, I have like 50 PDF documents. I don't have enough tokens to put everything together. Then what do I do? Okay, so we can say, oh, well, we can make the context longer so we can accompany more things. But actually what helps, I think in a lot of cases, is thinking about a wider context rather than a longer context. Okay, many times what we can do with long context is then take documents, summarize them so we can fit in a shorter context window, and that's probably good enough, okay? But for wider context, what we mean by wider context is looking at a larger framework, okay? So down here, right, we have at the top things that are faddish, okay, very quick to happen, like archive and things of this sort, but they only look at a very measured sense of progress, things that are metric and measured, but not necessarily in a broader sense, maybe not interdisciplinary, okay? But when we try to open up the window a little bit, okay, then we can say we have infrastructure, governance, culture, okay? These are bigger pockets of information that requires more deliberation. It requires us to imagine personas of different types, right? And LLMs can do that. You can ask an LLM to critique in many different styles, right? And many of us in these talks that we've seen today, as well as in posters, use LLMs with different personas to try to capture that. But we can make it even wider, okay? This comes back to one of the key reasons why we have universities in the first place. Okay, the university system, as it was imagined, especially in Germany under the Humboldtian model, was to try to address this problem of being able to solve wicked problems where many different intersections of areas come together and have an influence on what the solution is supposed to solve. Okay? So that's why we need the fast science, which is iterations over system 1, but also the slow science, which is of system 2, where we're integrating a much wider context, much wider field of view, and thinking about all of the implications that come from that. Okay? So the final part of my talk that I'm going to go through is the centaur. So it's 2026. Right? It's the year of the horse in Chinese mythology. And I'm sure all of us are also aware of this idea of a centaur, right? Is everyone familiar with that? Centaurs in chess are the combination of humans and chess solving systems, right? And we can think about the types of lessons that have come out from the chess community that might influence and help us think about what AI for science will look like going forward. So let's do that. So in 1998, Deep Blue defeated Garry Kasparov, right? He was humbled by the system that could search billions of chess positions per second. Okay, well, Is AI for science really like that? In certain cases, yes, right? We can do brute force search guided with Monte Carlo tree search or other things, right? To try to find parameters that fit certain areas. And as we heard from Cheng Lei earlier in his keynote, right? A lot of it has to do with exploring the space of possibilities widely. If you heard another keynote about astronomy earlier during AAAI, the idea of being able to sift out from all the terabytes of data, what are the key events are also very important, okay? So what he did, Gary Kasparov did, was formulate this idea of what is called advanced chess, right? Advanced chess is the idea that maybe, people plus chess solving systems, that can explore massive amounts of computational space can do a better job than AI agents alone. And yes, that proved to be true, okay? In 2005, around then, there were some tournaments in which such cases of centaur teams, whereas a human expert was guiding the reasoning of a system to check and find the right moves, actually won over expert tournaments, okay? So people who are more lay, were not expert trains with decades of chess background, they could actually come close to beating grandmasters, using this. And eventually, some of them beat the leading teams that were just human only and AI only. So there were cases of this doing well. But unless that wasn't to last, as of 2026, there are quite a number of web pages and indications that say, chess has run its course. When a human is guiding an engine, the engine can do better. Why is that? Because the magnitude of differences in these freestyle chess games isn't enough. Okay, the computational complexity is overshadowed by the ability of our AI systems to investigate good possibilities. There have been ways of trying to get around this. So if you know chess 960, this is the idea that you take the back rank where all of the powerful pieces are, and you just permute it at random on both sides. That makes a more interesting game. But even that can be easily solved by AI agents because it's only 3 magnitudes more of a search space. It's not that hard. Where am I going with this? This is my worry. Okay, as an educator, I am the vice dean of undergraduate students at NUS. Okay, I worry that we're not bringing humans along for the ride. Okay, so I asked ChatGPT a while to draw me a bimodal distribution. It didn't do a very good job, right? This is the joke that you see plastered on people's shirts. There are 10 types of students who understand, ones that do and ones that don't, right? So that's actually supposed to be read as 1-0, right? But my point is that even with things like AI for science, and we are not software engineers in the room, but I can guarantee you our software engineering brethren are much more worried about this, right? What happens when we release a whole bunch of junior software engineers that only know how to prompt? Are we in danger, or are we going to have a magnitude explosion of productivity? I think both. Both. So there was a talk given at Stanford where Andrew Ng asked his friend Lawrence Moroney to talk about what is the career in AI. Because so many people are studying online, right? They don't even need to go to Stanford. They're just going to watch the courses on YouTube, right? And they can do a good job, right? And he says, you know what? I need you to know when you should delegate your coding to an AI. Okay, like your senior software engineers, your professors, they can do it. Why? They already have the fundamental mastery of coding. They know what all of these things are. So there's not that much repercussions. But when people do this and they think that they're doing the right thing, is it always the case? All right, because every time you delegate to AI, you are incurring some type of technical debt, right? So technical debt, as is explained here, because he also pulled a class and they found out nobody knows what this term means. Technical debt means you make a conscious decision to prioritize productivity over understanding and mastery. Okay? And it can be because you have a deadline for your assignment. Your boss says we need to ship on Monday. It's already Tuesday. You know, all of these things are cause for that. Okay? So the question is there such thing as a good debt? And yes, there are. They can be when you have a very good specification of the problem, when you have clear objectives, all right, or there's a good business value for it. And most importantly for me is that there's human understanding in the loop, meaning that we know what the LLM is doing, okay? And we don't abdicate our responsibility for it. Just creating traces is insufficient. Okay, I'm almost finished. So you may have noticed that on December 31st of last year, MIT also released another paper, which has been giving its rounds, right? And this is AI use as cognitive debt. So it's a surrogate to technical debt. The idea is exactly the same, right? So they asked students, write an essay of this sort, okay? Must our achievements benefit others in order to make us truly happy, okay? So they had to do this assignment over 4 months, okay? One session a month, and they had 3 groups. Each group had a different modality. There was a group that was assigned to use LLMs to help them, a group that was assigned to use search engines but construct things on their own, and a final group that used their brains only, okay? The touch point on this is at the 4th session, they switched. Okay? The LLM using people, they had to use their brains. They weren't allowed to use LLMs in the final iteration. And the brain using people, they were allowed to complement their use using LLMs. And you can see where this is going. Okay? So this is not peer reviewed. I put it up there. They also made sure that everyone knows this, but it's good to think about whether these implications might hold true even for AI for science. Okay, I'll read it out to you. Brain connectivity systematically scaled down with the amount of external support, right? The brain only people exhibited the strongest. LLM assistance elicited the weakest overall coupling. And when they switched it to session 4, this is what they found. Participants showed weaker neural connectivity and under engagement in their fMRI scans, their EEG scans, okay? But the participants who owned their essays because they had shaped them from the ground up, they had higher recall. They could connect with what they wrote in the previous month when the LLM supplied them advice. So this is the key point that I want to drive, is that I'm worried that we as AI scientists, our community, could be unwittingly doing something if we're not careful, which is engineering a collapse of a centaur. Okay? AI plus human teams may not bring humans along for the ride, right? But we know we want that to happen. We want our scientists to be improved in productivity, not reliant on AI scientists to shape humanity's future. So my question to you is there such thing as good cognitive debt? Because we know there are such things as good debt, you know, good financial debt, good technical debt, okay? When do we know what the right balance is? So this is my last slide for you, okay? I want to say we have to think about man's search for meaning, right? Not just long context, but really the wider context of what it means to solve problems. What do we want to delegate to the LLM? What do we want human agency? What do we want to insist humans have to proof check, even though it's tedious? Because we need to build the muscle memory to be able to do those functions. We cannot outsource them. Okay, so thank you for your attention. And if you want the slides, they're there on the QR code.
Does anyone have questions?
Thank you for the very thought-provoking talk. My question is, do you have any thoughts on how we can encourage companies to adopt this mindset? I think a lot of companies are very much like output focused, and they're thinking, oh, how do we get our employees to be the most productive and efficient as possible? And they may not be as convinced about like this notion of degrading by excessive AI, LLM support, amongst other things that you mentioned. So yeah, just any initial thoughts you have on that.
It's hard to get a company that's motivated by the bottom line to do that. I think it really requires a lot of community support and realization from the ground, meaning our scientists have to understand what cognitive debt they're going into when they use such tools, right? Nowadays, we use all of these reading agents, to help us get better productivity so we can read faster. But you have to realize that you are outsourcing certain abilities to the AI agent to do, right? Part of that, I think, also lies with the locus of control from our educational institutions, which is why I think MIT led the way here in trying to highlight that there is possibly a problem on the horizon. We are going through one of the greatest natural experiments, right? Nobody said we had to use AI, right? But we are using it for every corner of life, right?
So basically a ground up approach to kind of convince them of the negative effects.
I think it requires work on every aspect. So it could be from the ground up. It could be scientists saying that they need to pay attention to this. It could be AI scientists like ourselves building in nudging aspects that help our scientists proof check all of the things, right? Because just because you expose an execution log and a trace doesn't mean that we're going to check it, okay? I mean, of course, if you have to archive your paper by tomorrow, are you going to check the appendices and all the traces, or are you going to concentrate on your main part of your paper, right? It's very hard to make that statement.
Thank you.
Thank you very much for the presentation. I have a quick question. So if we see the problem of human knowledge and our key objective is to expand human knowledge, then I think we should not worry that much about the death of the senator, because basically if the objective is to increase knowledge and optimized and automated research is leading to in this direction, then we have nothing to worry about. Again, and following up on my same thought, I think we can still solve the problem you raised, which is worrying about the collapse of human capacities and human IQ, if we can say. Then we can again build some. Just a thought. We can build like a gym for intelligence, like we do now for our muscles. So basically, humans used to be much stronger when they were maybe hundreds or thousands of years ago, when they used to take stones, build big things, and so on. And now we are much weaker because we are lazy and doing nothing compared to them. And basically, the solution was to go to the gym and do some sports. So it could be possible that in 10 years from now, humans will actually be doing something similar, going to the intelligence gym, and basically we may use automated research to push the boundaries of research. And if it happens that some humans remain interested in this and have some plus, then basically they can lead some efforts into the research and being their own scientists or collaborate with AI. But my point is, I think we cannot stop this direction as long as our objective is to expand knowledge.
Thanks very much for your comments. I totally agree with you. I think your gym analogy is a great one. I think, we have to ask ourselves, what are we actually wanting from research, right? If we want to better knowledge, definitely we should use at all means possible to further knowledge. The question I have for us is, what counterpart do we want to play in this, right? If it turns out that AI scientists can teach AI scientists how to do better in some type of reinforcement loop, and no humans need to be learning or anything of that sort, is that a future that we're willing to delegate, right? Because it comes back to the questions of AGI. I mean, if we have AGI that is benign, then of course there's no problem, right? But if AGI can be subverted in some way, okay, does that cause problems for us because our protectors, our nurturers don't have our best interests in mind, right? Yeah, but I really like your analogy of the gym. Maybe just like people do leak code these days, maybe we'll have research code or whatever that helps you figure out problems, right? Like technical interviews that we do for postdocs, for example. Yeah.
I have a quick question on
Yes.
the education front. I guess we're not in 2035 yet, so I guess coming back to 26, given your educational role, what's your thoughts on AI usage policy? Like, have you seen a trend emerging in US? What's your thoughts in general and practically, especially speaking on how much you're enforcing it? Are you changing the exam format, so on and so forth?
Okay, yeah, so this is an open problem that a lot of universities are trying to tackle too. So I can speak that NUS allows AI use for any take-home assignment. So there's no way we are going to tell students that they're not allowed to use AI because frankly, we have no way of policing that. Okay. That said, that forces the instructor to rethink the modality of how they assess. If they want to assess mastery of something that's directly something that can be accomplished by an AI, they need to do it under proctored conditions. Now, this is also not very helpful for a lot of cases where you would want to be able to give a take-home assignment for them to complete on their own, but it doesn't create a level playing ground. This is why we do that. The second part of that answer is because, our students, they also have no choice. If they decide not to use AI, they will lose out to people using AI. So there needs to be this this natural environment where we are testing students with the same intention that they will see in the industry. It doesn't make sense for them to be coding Python libraries without any AI assistance if they go to internships and they're forced to use Cursor or Windsurf. I hope that answers your question.
Yeah, thank you.
Okay, one last question.
Question. So out of all these fields, right, where, I mean, we are discussing how this AI gets integrated into society in principle, right? So by all measurements, but we also know somehow that AI most likely affected in this first period coding, programming, software engineering, right? What you mentioned, right? And we can also learn a little bit how professional community like software engineers how the community reacted from excitement to disappointment, kind of swinging a little bit. And only now, slowly, somehow this gets established field, or at least people discuss how to approach this in a proper way to have some kind of balance between pros and cons, right, of using AI. I would expect from on a little bit more abstract level, right? So that other communities will have the same kind of dynamics, trying to find the proper balance. Well, it's true that also at the same time AI is evolving, right? So it's not that we will have some kind of stable tools, right? So, but yeah, my point is just that we can learn something from AI being integrated into software engineering, right? And seeing how this field where we are part of, I guess, reacted, right? And education, yes, it's a big issue, right? But likely it will be something similar conceptually at least, yeah. For other areas like lawyers and I don't know, similar, but with a little bit bigger, let's say, time spans. Would you agree with this kind of
I would in general. There's definitely a diachronic playing field happening between disciplines. So ones that have digital infrastructure and data are most affected. But I think one of the worries that we have is that, as humans, we only have a certain capability to adapt to change, right? So when students learn certain techniques and those techniques are outdated in 6 months, how are they supposed to respond to that, right? They have to adapt faster and faster. And it becomes very a loss of agency, if I can say, that they don't seem to have control over what they learn and whether those skills are still relevant in the next era of change. When we talk about technology in the last, century or so, it was much more gradual. There was time to adjust, there was time to legislate. And now that is pretty much out the window. Things are moving so fast. Yeah. So again, there's no answers to my talk. It's more a chance for you to reflect, catalyze your thought, and I'd welcome a lot of engagement because I think these issues are important. They are just as important as the AI scientist work that we're doing as a community here. So thank you very much.
Thank you, Prof. Ming, for